Right, let's look at acids and bases. This is a new topic, and a lot of this is going to be revision. You covered acids and alkalis and bases during Key Stage 3, so years 7 to 9, and you've got a basic idea of what this topic's about. Now, you saw this, the pH scale. These colours refer to universal indicator, which is what's called a full range indicator. So they give you not only that something's acid or acidic and something's alkaline, but also they tell you when something's neutral, a little bit alkaline, a little bit acidic, etc. That's why it's called a full range. So you get strong acid, weak acid, neutral, weak alkali, strong alkali. Okay, just a little bit of a revision of the basics. Have a read through these pages and put the substances above at the appropriate point on the scale. Stop me for a minute and see where they would go. Okay, so strong acid is there, isn't it? That's hydrochloric acid, which is one of our classic strong acids. Sodium hydroxide, B, is a strong alkali. 0.1 m means 0.1 moles per decimeter cubed. It's a measure of its concentration. So you'll have noticed that there's a 0 on this scale. So if this acid, this hydrochloric acid, were a greater concentration, 1 molar for example, then that A would be lower. It would be more acidic. And if this was 1 molar sodium hydroxide, that would be higher. Okay, so we've got the dimension of concentration there as well. Lemon juice, you know, is acidic. That's about 2. Contains citric acid. Baking powder is slightly alkaline. When dissolved, it tends to be hydrogen carbonates and they're slightly alkaline. Vinegar is a weak acid. It contains ethanoic acid. It's down there. And oven cleaner is actually a very strong alkali. It is at pH 13. It's used to clean off the dirt from the inside of ovens. Okay. Right, indicators. So, indicators. What do we use them for? Well, they tell us, or they give us an idea of the pH of a substance in solution. We really can only talk about acids and alkalis when they're dissolved in water. We should only talk about them as solutions. Universal indicators, I mentioned, is a mixture or blend of indicators, and it gives us a full range of colours. It's a full range indicator. Other indicators you must know, you must learn these. Litmus, it can be as a solution or it can be in paper form. In acid it's red and in alkali it's blue. Phenolphthalein, which is used in titrations, we mentioned earlier this year, is colourless in acidic solution and pink in alkali. Methyl orange is red in acid and yellow in alkali. You need to learn these colours. There's another way of measuring the pH of a solution, and that's using something called a pH meter. We have these ones in school. There's just a different variety, and they give you the actual number on the screens of the pH of the solution. So that's a basic introduction to acids, alkalis, and indicators. Have a look at the pages and answer the questions.